continue on. Now, once that we've covered the clock, we actually have quite a bit to cover with this content now. So the content, the painted objects are kind of glowy. They stretch based on how fast you're moving the mouse in either X or Y. And we can change the glow, we can change the opacity, and we can change the time that it lives. So let's look at the fact that we used to use, let me jump over to Click Position Manager. So down here is our create situation. Users clicked, and we figure out what to create. We used to call this game object create primitive, and just use a very default object from Unity. But now we're getting a little bit more sophisticated, and we have to start creating our own stuff. So now we can look at prefabs. So to do that, let's just create something. Usually start off with a sphere. So I'm just going to create a sphere and call it my sphere. And I'm just going to zero out its position and frame up on it. And this is what we're creating. We call that create primitive. And it's very useful. But some additions we need now are, besides a collider, we're going to upgrade the material. And we need to actually put it on a physics layer, because we need to know if we're clicking on it to destroy it. And just these objects, we don't want to destroy the clock parts. So we're actually going to change or configure this game object some more. I'm just going to move it so it's not sitting on the sun icon for right now. One thing it needs is it needs to be on this painted object layer, so we can, when we do array casting, we can tell if we're hitting our painted objects or our clock face. So we do need to switch up to the painted object layer. And another thing here, we're going to be introducing opacity and emission. We're going to be upgrading our standard shader usage. So we can go into materials, and we can create a new material. So it's a Friday 1 p.m. class, let's call it that. And here we are indeed using standard. In last classes, we did use some unlit color materials for the clocks. We're not using that right now. We're just going to use standard. And the big upgrade is here, rendering mode. We're going to switch from opaque to transparent. So to see this, I'm going to drag it onto our object, my sphere. And if you notice here, I dragged it onto the object in the hierarchy, or you can also drag it in the inspector. But what's important to see is that we're not using the default material anymore. So I'm going to go back to editing the material, and you can see it right on my object now. So I'm just going to change it red, which, big deal, we were able to do that before. But now, since I have rendering mode to transparent, which is more expensive, now I can mess with the alpha, or the opacity. A for alpha, and this is an idea of opacity or transparency. So the more alpha, the more opaque. Less alpha, the more transparent. And it makes it almost like a bubble. So, great. Now we can mess with the alpha. That's going to be a big upgrade to our visuals. And I'm going to go down here and turn on emission. And it doesn't do anything because the color default is black. But notice as I change the emission color up, it starts adding a glow, like it's a light bulb. So we can add a glow or an emission to this object. And whenever it's black, it's not going to emit anything. The black emission color just doesn't change anything. You notice as you move up the intensity, the value, as you're moving up the value, it's going to glow more, and you can tint the color. Like here it's red, here I can tint it as like a yellow, green, blue. And so you can like pull down the color a little bit, and you get that like red underneath, and then mixing like a different emission color. So that might be interesting. I might upgrade that later, but usually I just take whatever the base color is, I just kind of tint it, give it like that same color tinting in the emission, just to make it look like it's glowing. So now we have this transparent rendering mode. We can mess around with the alpha. We turned on emission, so now we can mess with the emission color. So we have an upgraded shader. So now this object has been a new material has been added to it and a new layer. And how do we save that information? How do we save out this game object so that we can use it later? Now we've customized it. So this is the ideas of prefabs. So prefab is just a game object that's been saved to the file disk so that you can use it later. So for example, like all these are game objects and they're in the hierarchy and they're just sitting in memory. But that means they can be forgotten very easily. And normally they just get all saved up in the scene so that you can open it later. So then the scene gets saved to the file disk. But what if I want to save the game objects to the file disk so that I can just create them at will? And all you have to do is just drag it down into your asset. So I create a folder. And here I just have my sphere 1. One mistake I did was I didn't zero out the position. So here I'm clicking on the actual prefabs, save to file disk, and notice it's .prefab. And notice it's a blue cube, and everything that's not a prefab is like just an empty, like a black cube. So the clock is coming from a prefab. This my sphere is coming from a prefab. So notice you click on this arrow and you can like go into the prefab and edit it if you needed to. So this is the one I just created. I did forget you have to zero out the position because you reuse, we're going to update that often. But now that I saved it, I can actually delete this because it's just a reference. It's just sitting in memory. It's a copy of this prefab. Like you can just drag it in and create again. And we're going to be doing that, but with code. And all of your settings are saved. So that's what a prefab is. A game object that you customized and you save to the file disk so that you can create it or instantiate it at will. So how do we reference those and then use this instantiate method? So here we have public game objects, painted object 0, 1, 2. These are the 3 that we're going to be referencing. For me, I do sphere, cube, and cylinder, but you can do what you want. Then we're also going to make an explosion prefab too that we can instantiate. So notice prefabs are referenced as game objects. There is no like prefab class. The idea of a prefab is that it's just a game object saved to disk. So just to show you about the explosion that we will be eventually creating, if you right click and then or left click to create and then right click to destroy, we have this type of prefab of explosion. All right. So I'll be covering how to create the explosion a little bit, but notice that painted object 0, 1, 2 and explosion, these are all prefabs. They've all got that blue cube. They're all coming from the file system as opposed to something like this. Notice this mouse pointer. Reference game object is an input variable. It's referencing a game object. It's referencing a black cube. And if I click on it, it's this game object. So be aware of the differences between a prefab and a game object. And we're connecting up our prefabs here. This painted object 0, 1, and 2. And this is what we're referencing that we're going to create from now on. So how do we do that? So let's go down into the create part of our update loop, which is here. Notice we have our switch statement. And this is saying switch on shape. This thing defaults to 0, but the user is allowed to change it through the dropdown. And notice when we define when we figure out what we're going to create, we're not using this create primitive method call. We're calling this instantiate. And what's going to happen is we have to pass in a game object that we want to instantiate, and then its position and its rotation. So it's not just one input now. It's 3, although there's different method calls for this. So we're passing in painted object 0, 0, 1, and 2. And remember, these are not live in the scene at the moment. These are prefabs. They're almost like copies, like classes sitting on the hard drive. You know, they're not live in our project, in our memory. And then where are we placing it? Well, we're going to place it still at click position. We still did the same process with click position, figuring out where to place stuff. In the rotation, just quaternion.identity. just means not 0. Just give it no rotation. Give it a rotation of 0. Identity just means a 0 rotation. So we instantiate whatever, and we're going to return back a game object. And then we have to remember it. So we set our reference, our object reference, our variable of type game object. We set it to whatever this thing creates so that we can use it later. All right, so these are prefabs, and they sit on your file drive, and these will be referencing prefabs. Now, the last one was this particle system. So this is, if you go under game object, effects, and particle system, this is just, and you click on it, it has like its own little simulated time to show you what it would look like. It's like this little simulated system. And in this case, the default one is just these like white spheres that are kind of faded out. And it just looks like, in this case, nothing too much, just like these little whiffs of smoke coming up. But you can make it look like water, smoke, fire, magical stuff, anything you want. So they're really interesting to play around with, but they're not in this part of the class. But if you just drag it down into your assets, you'll make a prefab of that particle system. And you can instantiate them and destroy them at will also. So before I move on with creating, let me just, since we just made this thing and we made the physics layer on it, let me go up to this section here, which is our right click to destroy. So notice it's a right drag. Sorry, not a right click, a right drag. We go in here, we still create our screen point array. We have our array and raycast hit variables. We pass them into arraycast, and if we do hit something based on where the user is clicking, we have to check. Okay, whatever we hit, grab its transform, go up to its game object, check the layer. Is it 12 for painted object? If so, we're going to destroy that object, that game object. And it's not the clock, so we're safe. We did our checks. And then we're going to instantiate that explosion prefab. We're going to make a game object from that explosion prefab, place it wherever we hit, go grab its transform, its position. So we place the explosion right where we just deleted something and a 0 rotation, and then we destroy that thing 1 second later. And that's how we get explosions when we right click. Cool. So I'm going to cover, this is how we're getting a stretchy forminess to the scale. I'm going to cover that next, because what we just did is we messed with the material to get opacity and emission going. So I'm going to cover that. So this section is changing the color and the emission. And this we're going to ignore. This is for the next section. This is saying, hey, if we have other game objects underneath, like you could have like 3 spheres and collections of different primitives. And this is for section 4. How do we loop through and see if we have other stuff underneath? So just ignore this for this section. This has to deal with animation. And similar note, just ignore it for the next section. And I'm going to get down this part later. So I'm going to come back up here, and I want to cover this part. So this says if the primitive that we just created, the game object we just instantiated, we're going to check if it has a render at the level. So this is new. We've always been doing get component, and it's a little unsafe. Now I'll introduce you to a safer way to do things when you handle object references. So it's saying, hey, whatever we just created, go see if there's a component on it of type renderer. So let me just paint something again. So if I click on something I just painted, and if I had a reference to this game object and I said get component render, it would return a reference to this object. Now let's just say for whatever reason I ran it on my camera. So it'd say, hey, go get, we have a reference to this game object that says get component renderer. Well, it has a transform, a camera, and an audio listener, but it doesn't have a render component. So it actually, that call would return back null. meaning it didn't find anything. That the reference is empty. There is no render component on this object. So I'm pretty safe. I know what I'm creating, and I know that there's a render at the root. But later on, our prefabs get a little bit more complicated, and the root might not have a render. There might be like game objects underneath that have renders. So let's get used to looking at something like this. So whatever game object we just created, get component. Okay, which one? Render. But now let's check it. If it's not equal to null, we will continue accessing it. Otherwise, if it is null, it would go here and we do nothing. Just note that if you just tried to access parts of the render component, like if you did this, like get me the render, and then go get me the material, this would return an error and you'd crash out if this was null. So if you try to do this on a camera game object or something else, we're going to get a crash out because this thing is null. It's pointing to nothing, and then you're trying to reference something within it. So just check these type of checks. Is this not equal to null? Awesome. Let's actually do more processing. It's important. So next is let's create a new color object. And you've seen this before. We just pass in a random red, green, and blue based on our sliders, but this is new. We have opacity strength. So this is a new field up here, and it's defaulting to half alpha. But we'll let the user also manipulate that if they choose to. So in that case, we're just saving it to this variable here, which these two might be new. So these are global fields up here that their type property, their type color, and these are their names. And I use them in, throughout the update and also in other methods. So they're just available up top globally throughout the object. So now that we create a color, we're going to go into what we just created, get its renderer component, and go into its material property, go into that its color, and set it to whatever we just did. Now we can mess around with the emission. So emission is going to be a new color object, and it's going to be whatever we just established is our red multiplied by emission strength, which is also just defaults to 0.5. Grab the green float from the color object. Remember, color is like basically a vector 4, and so any vectors 2, 3, 4, you can reference their floats. So usually with vector 3s, you can say .xyz or RGB, and with the vector 4, you have RGBA, X, Y, Z, W. But here we're just grabbing the green that we just figured out, multiply by emission strength. In here, we're grabbing the blue and just multiplying by the emission strength. So this is creating a color object, which is vector 4. But when you don't specify the fourth one or A, it just sets it to 1. So anyway, we figured out our emission, which is based off our base color. And then we have to go back into the render and get into the material. And this time we don't have a nice little property. We have to call the set color method, and then saying like, okay, which color, which property do you wish to set? And this is called the emission color, because I showed you when I was setting the material. That this is color and this is emission color. So there's many different types of properties up here that you can set, but when you say set color, you have to pass in the name, and there's many different parameters you can tweak, but this one we're just gonna tweak the emission color. We're gonna pass in with the new variable, new object it will be referenced to. You could also do this to color, so it'd be set color, and it'd just be underscore color, which I do it later on to show you the differences. But since that is changed so much, there's just a property, just kind of like how transform has like a quick property to it. All right, so we're done with there, and we've just set the color with the opacity and the emission color. So since we just talked about these two things, let's go into the UI and be like, well, we have this glow and opacity slider. And here they are. So I have my color sliders. I just kind of grouped them up nicely. So the size slider we've gone through before. Now we have a glow slider. I just copied the slider and renamed it and connected it up differently. So the glow slider will go from 0 to 1 with a default of 0.5. And it's going to call the change emission strength public method on our click position manager. And change opacity is very similar. It's just we don't go to dead 0 because then it would be like invisible. So it's just a small number to 1, defaults to 0.5, and we have change opacity strength right there. So now we have two public methods that we need to investigate. And here we have change emission, and here's change opacity, which I'll cover first. So let's ignore this for each loop right now and say, okay, a float is coming in. The user changed the slider, and we just update our opacity strength with it. And that's going to go into our update loop and will impact our future painted objects. But you've seen that type of flow before with these public methods. But what's new here is, well, what if we wanted to impact currently existing, the painted objects that are currently sitting on the screen? Well, for that, we have to go into, and we've seen this for each. We're going to loop through all the child transforms in the current transform, which is the click detector. And I'll just unclick time destroy, and I'll just paint. And all this stuff is sitting under click detector. So we're going to loop through each one. Then we're going to check. Okay, let's go up to its game object. Let's get the renderer component, see if it's not null, which means it exists, so we can do something with it. And then let's go into its renderer. Let's get its material, and let's get its color. And it's saying, like, well, which color property do you want? And remember that underscore color, it represents that base color. So now we have access to it. We store it in this global variable that I showed you up top. And then we're going to grab the alpha.a, and we're going to set temp to it. Remember, temp is coming in because the user is changing the slider, and that comes in and changes the alpha property on this that we just got from as we're looping through each currently existing painted object. So we're just sitting on 1 right now, and we change the A, but we keep the RGB. And then we go back into the renderer, get the renderer, get the material. Now we're calling set color. So remember, before I use the color property here, I'm going to say set color just to show you the other way. And you pass in the name. In this case, this is the base color name. And then you're going to pass in the new variable. And the A has been updated. So we loop through everything that currently exists, and we just get all their colors. And then let me lower the glow so you can see a little bit. And then we get all their colors, loop through each one of these, get their colors, and then update their alpha, the .a only, of the new opacity value between 0 and 1. And that's how come we can update now the currently existing painted strokes. Pretty cool. And this one I'm going to ignore for right now. This is when you have prefabs that have more game objects underneath them, which we don't have at the moment. So we can ignore this. But we should be familiar with the for each, looping through children. And for each child, we check if it has a render, and then we mess around with it, updating the alpha of its currently existing color. So we have get color and then setting the color. Get your color, set the alpha on it, and set it back. And so emission follows the same process. Float comes in, we update our emission strength, but then we loop through, and this is for our future paint strokes, but then we loop through whatever we currently have, see if they have a render, grab their color. Remember, emission is a little different. We want to grab the color, and then we want to mix it with this emission strength. So we grab the red, the mixtures of red, green, and blue, R, G, and B, and we just multiply it by temp because that's our new emission color. And then we're getting the color, the base color, and multiplying this separate RGB by this new emission strength that's coming in. And then we're setting the color based on what we mixed up and we made a new color. We just set the emission strength property. So set color, what are we setting? The emission color, and we're passing in that new emission. In this one, we're going to ignore this part. That's for section 4. And now we can update the glow on it. And actually we can update the colors now. Green and blue and red. And that's because I've updated change blue, green, and red. So the float comes in, and yes, we still update blue, the property that we use in the update loop. But we also, for each, we loop through the children, and if the children have renderers, we're going to update their colors in a similar fashion. And while I'm in here, I'll just show you that, well, we also go back to the UI. Notice how these numbers change. The amount of blue is now 55. The amount of green is now 76. The amount of red is now 44 from 0 to 100. And so how do we do that? Well, these are little just text elements, text components. And so we just connected them up. And you've seen how we connect them up. Grab the text field. We just take those 0 to 1. The blue is normally between 0 and 1. We just multiply it by 100, and then we just chop off the decimals. So it's a nice, easy 0 to 100 for users. All right. And then all that's left in the UI is the timer here. So when we're creating, if time destroy is on, we're going to go in here. So this line, just ignore this right now because this is set to false. I start using this property later, but this is a bool up top and it's just defaulting to false, and we're not changing it right now. So this part of the code won't run. So it's just this line right here. Destroy this object after a certain amount of time. Normally this is always set to 3, but we do have a timer slider now, this one here. And it's a slider. You're familiar with them, but it goes from 1 to 5, defaults to 3, but I turned on whole numbers. So now we just have a representation of whole numbers in that range. And this, when the user interacts with that, we call change time to destroy. I think that's L at the bottom. Yeah, public method, float comes in, our time to destroy gets updated, and so that's how the next time that we create an update loop reads that. And then we also go back to the UI. We have a nice little text element, so we take that float and we take off the decimal and we just add a nice little string after it, sec for second. And that's where we get this 4 second, 2 second, 1 second. Cool. And last but not least, I'm going to cover how we have the painted stroke change. How does it get really long horizontally, vertically, or even if I'm going diagonally, it makes nice bigger, larger, but just fatter paint bubbles. So how am I doing that? So for that, we have our click position, right? Variable here, type vector3. But now we also have a last click position. And it's a vector3 as well. And so now we're going to keep track of where the user was last frame to this frame, and we can compare how big the X's and the Y differences are so that we can know how to mess with the size of setting the scale. So if I come down here, I'll return to this later, but we go into our I should say I default. I don't think I preface that. The last click position gets defaulted to vector 3.0, because it's it hasn't happened yet. But just know that when we go into our painting situation, we're left clicking. We're making use of click position, right? And we're doing a bunch of stuff with click position. And notice all the way at the bottom, we say last click position equals click position. So we do a bunch of stuff in our update loop, and we've used this click position up. But I just want to store it. All the way at the end, I'm done with it. I'm just going to set last click position to that. So next frame, next update loop, we can remember what our click position was last frame, and we can make use of it. So that's how I'm remembering what our last click position was. And how am I using that? So in our area of code right here where we mess with the scale, we say if last click position is vector 3.0, meaning we haven't set it yet. The user is like the first part of a user stroke. Then we just do what we normally do. Take the local scale and set it equal to a new vector 3 of a randomness between 0.1 and 1 times this size factor that the user can control, right? Else, this is not zeroed out. This means we're like in the middle of a stroke, so that we do have a last click position that we can mess around with. Note that I'm creating 3 floats, an X, a Y, and a Z. And then I'm putting them into the local scale. So I'm making a new vector 3 with them, and I'm just updating the local scale. So we're doing something a little different. Note that the Z is just like the average of the X and the Y. And the reason I did that is because when you mess with the X scale, like it's really obvious. When you mess with the Y scale, it's really obvious. But the Z scale isn't so obvious because it's coming directly toward the camera view. So I don't really mess with that much. That's why it's just a mixture of X and Y, an average of X and Y. It's really these two that are really important. So here we have some math functions coming in here. And we have like function calls within function calls, so it can be a little easier to read, but float X equals, and if I come to this part, this is really like, this is really the heart of it right here. All right. So what this is doing is taking our last click position dot X, take the X part of our last click position, so vector 3, and subtract our current X, our click position dot X. You can do one or the other. What's important is that you take one of the X's and you subtract the other X, and you're going to get a difference. It's like, where were we last frame in left and right, and where are we now left and right? That tells us how fast the user is moving their mouse. And since it can be positive or negative, what we do is we go into this math library. So it's coming from Unity Engine namespace, math F, F for float. So it's math functions that deal with decimals. And there's a lot of good methods in here, but the one I'm currently using right here is the absolute value. That's why it doesn't matter how we do this subtraction, because it'll always end up being positive. So now we have the difference in the X between last frame and first frame. And notice that the Y is doing, we're calculating Y similarly. We're just seeing the difference in the Y. And we're multiplying it by a random range of whatever our size variable. Like it starts off at 0.5, but the user can change it. So random range minimum of size and a maximum of size times 6. I just found through testing that this was a nice randomness added to it. And all of this then goes into another math function called clamp. Clamp is important. It's like you can pass in a value. It'll be clamped from the min to the max. So let's just say we pass in a 0.5 and our min and max is 0 and 1. Well, 0.5 is within 0 and 1, so you'll get 0.5 back. But let's say we pass in a 1.1 within a clamping range of 0 to 1. Well, it's past our max, so we get the max back. We get 1 back. So it's really helpful when you don't know where your calculations are going to be a little random. So our minimum is 0.1 because we don't want a scale of negative or 0. And our max is just size times 10. And I just tested that. That felt right. I don't want it to be so big that it fills up the whole screen. So that's how we get our X and our Y values based on how much the user is moving their mouse from frame to frame. And then we just set our local scale to that. And that's it. I covered the glow slider, the opacity slider. I covered how we can update current and future painted objects. We can right click to delete because it's on layer painted object. I showed you prefabs and the new material settings we're using with the standard shader. And different time scales. I gotta delete this sphere here. I think he's blocking my ray casting. Cool. And quick and long lives. Yeah, that's everything you need for this quiz.